Hello, hello. Shrikant, why did your friends call you K-Dog? So we'll start in about 2 minutes. Hi, Kevin. Hello, hello. Hi, hi. All right, shall we get started? You guys got my email, no? About credit, no credit stuff. Just make sure that we are on the same page over there. So bottom line is this, okay? If you are keeping up your work and do your homework, etc., then you come to class, then there should be no reason for you to not get credit. Even if your grades are relatively lower before, in order to provide everyone with a good chance to pass, I think it's common policy that across all courses that teachers are a little bit more open about providing opportunities. So basically, bottom line, if you trust me enough, if you come to class, coming to these online meetings, and you've been doing your homework, participating, then there should be no reason for you to not get credit. Okay? That's pretty much it. I mean, there's not much to talk about. If you don't turn in your homework, you start slacking off, doing nothing, then obviously it will be hard for me to justify passing you, Because you know how it is, right? If you do your work, then it's easy for me to pass you. If you don't do your work, then it's hard for me to pass you. I mean, I shouldn't have to explain this. This has always been the case, right? Except now you even take away the high-stake exams. So I would say there should be no, you have to try to fail, basically. Like, you have to like purposely not do stuff to fail. If that makes sense. Does it even make sense? Okay. All right. So we are in the second part of this, which is today we're going to talk about recursive homework. Recursive sequence, not homework. Why would I say homework? Because I just click on some homework thing. Give me 1 sec. Okay. So, here. So before we start, how about you work on these two? All right, these two problems real quick. I'll give you about 2 minutes, and then we'll start from there, okay? So try these two problems real quick. Hi. Start with these two problems. Hi. All right. All right. So we are going to look at this. All right. So first thing is that you have 7, 15, 23, blah, 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 k, blah, blah. So what's the pattern here? What are we doing here? Isn't it plus 8 each time? So in other words, if I know this is a k, then the next term will be what? K plus 8. All right, make sense? Yeah? And then now you need to write n term explicitly, right? So n term explicitly, this is an arithmetic, right? Arithmetic sequence, which means it has a common difference. Remember the formula we use? A1 plus n minus 1 difference, right? And difference here is 8. First term is 7. Okay, so you can do it like that, and you can simplify if you want to, which is going to be 8n minus 1, I think, if you multiply it out. Okay? So that's n term. We're going to talk about recursive in a bit, so we'll save that recursive part. Next part, 1.5, 3, 6, blah, 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 k. Pretty obvious, you're timesing 2, right? Multiplying by 2. So the next part will be 2k. And since we're multiplying by 2, we call this a geometric sequence. So we have what? Gn equals G1. Same thing as this one, except instead of adding, you're multiplying. So times r to the n minus 1, where r is your ratio. In this case, r would be, G1, first term would be 1.5. Your r is 2, because you're multiplying by 2, to the n minus 1 power. That would be your Gn, okay? Questions about these two? Okay, this is something we talked about before. We call these kind of formula explicit formula. Why? Because everything is explicitly defined. As long as you give me a term number, I can give you a any term. If you want 100 terms, just plug in 100, n equals 100, and I'll give you whatever term you want. That's called explicit. There's also recursive formula. Recursive means happening over and over again, right? So to find the next term, okay, if given the current term or previous term, okay, current term, okay, this term, okay, next term given the current term. Make sense? Okay, so there are many ways to define recursive, but primarily you can just do this following. So I do it like this. So to define the next term, okay, I use this term. So if you look at the number 1, what is your pattern? You are trying to add 8 each time, right? Add 8 each time, so that means this is called next term, Tn plus 1 next. Tn is this term, whatever this term is, plus 8. So whatever term I am here, I add 8, I get the next term. Okay? Similarly, you can do this for the second one as well, which is Tn plus 1 equals what? 2 times Tn, right? That's what the next one look like, because you're multiplying this one by 2 and you get the next one. Okay? Now, before we continue over here, there's an incomplete part here that I want to talk about. But I want to discover something on your own. So they say when using a recursive form, you must blank, otherwise it's not clear what sequence you have. So try writing recursive for both of these. See what you get. Okay? Try writing recursive for these. So basically next term, right, n plus 1 equals this term. What's the pattern here? What is the pattern? Plus 2, right? Plus 2. Same thing here. Tn plus 1 equals Tn plus 2, right? Because you're adding 2 each time to each term. So then the question is, how can I distinguish between the two? That means we have to add a reference point, which means usually we give the first term. In this case, first term here is 1. First term here is 2. Together, this will define the sequence. Okay? So in other words, you would define here too, right? T1 is 7, and the other one, T1 is 1.5. Okay? Without the referencing point, okay, it's too difficult to determine what kind of sequence you have. Okay, so usually you define, doesn't have to be term 1, it could be term anything, but we'll just put term 1 for now. Okay? Make sense? Alright, so can you write recursive definition for each of these? Give you 2 minutes. Okay? Alright, since you're working right now, actually it shouldn't take that long. So since you're working right now, this is a little tricky though. Since you're doing it right now, let's take attendance while you're working on it. This is a very interesting problem, that's why. So if you're here, just say you're here, then and take attendance for formality of it. It's easier to count when you all say it together. Seems like I'm missing quite a few people. Let me see. Is Tanya here? So missing a Tanya. Oh, hi Tanya. Oh, I missed you. Haha. Is Tingya here? But Viva. No Viva. Okay. No Tingya either. Is Edward here? Edward? No Edward? About was Sabrina? No Sabrina? Oh, hi Edward. Oops. Do we have a Kenneth Young? No Kenneth Young? Oh, hi Tingya. So I'm missing Sabrina, Viva, and Kenneth. Kenny Young. Where's Sabrina? Sabrina, where are you? Tell her to email me, okay? Tell her to email me. Okay. It is a glitch. If your if your chat is not working, just send me an email, all right? And then tell me that you're watching, and that's all good. So I'm missing Viva and Kenny, right? All right. So Viva and Kenny, if you guys are watching, send me an email, all right? And yeah, so this part, right? You're trying to define recursive, okay? So you're plus 2, what? Plus 3, plus 4, plus 5, right? So if you want to define recursive, right, you have to look at the pattern, okay? N plus 1, Tn plus 1 is equal to Tn. You want to add something, right? So let's see. So if Tn is first term, right? If n is 1, then the second term you add is what? What are you adding? You're adding 2, right? So when n is 1, you add 2, right? Because it's 1 to 3, right? When n is 2, you add 3, right? Because it's from 3 to 6. And when n is 3, then you add 4, right? So what are you adding? You're adding 1 more than the term number, right? So it'll be plus n plus 1, like that. And obviously T1 is 1, okay? So this will give you a recursive. Kind of make sense? All right, so you grasp the pattern, and then you go from there, okay? Similarly, you look at the second one. This one is you're adding 2, adding 4, adding 6, right? Keep going. So what are you adding? Tn plus 1 is equal to Tn plus something, right? You're adding. So what you're actually adding is, let's observe, okay? When n is 1, you add from 1 to 3, right? That's plus 2. Yeah. When n is 2, you add from 3 to 7, that's plus 4. When n is 3, you add from 7 to 13, that's plus 6. So what's the pattern here? You're adding 2 times the term number, right? So 2, 4, 6, right? 2, 1, 2, 2, 4, 3, 6. So it's 2n. Okay, obviously T1 is still 1. Okay? All right, let's test survey some comfort level. If you were have to scale your understanding from 1 to 10, 1 being I have no idea what I'm doing, 10 being this is easy, can we move on? Give me a number. Type it in the chat, okay? It's not graded, so type what you want, okay? Wow, the confidence. Gee. 8 is not bad. Eight, 7, 7, 8. So basically you have to grasp the pattern between each terms, right? Which is what you've been doing. But now, compared to like, remember when we did general sequence where you have to kind of grasp what the pattern is and trying to figure out the equation? This is much easier to do, right? Because that, we'll review that in a bit, so it reminds you what you've been through, okay? But that was more general. This should be a little bit more intuitive, right? Because you're just grasping the pattern between two terms, right? Between the successive terms, not in terms of the whole thing, okay? All right, so let's flip to the next page. Let's talk about some interesting problems, okay? So next part is, so read the question first, okay? We're gonna read this because this is quite an interesting kind of geometry-like. So say, let Rn represent the number of regions formed when n lines are drawn in a plane such that no two lines are parallel and no three lines are concurrent. Find the recursive formula for this, and then find the explicit formula. Comfort level after reading this problem, 1 to 10. 1 being, say that again, 10 being, this is easy, I got this. Wow, Arjun, wow. Wow. Five. Okay. 5's not bad. At least you kind of know what it's talking about. 1. Yep. Exactly what I expect. 8 is not bad. The hard part is that sometimes it's hard to grasp what they're asking for. 4, 1. Okay. So let's look at what it's asking for. Okay, so a plane, right? When n equals 1, okay? When n equals 1, that means I'm using one line, okay? N is 1. One line to cut through two planes. How many region are n? That is how many region. How many region do I have? I have one region here, one region here. Right? One line cuts into two regions, so Rn is 2. Or sorry, R1 is 2. Okay, R1 is 2. Okay, that's a representation, right? When n is 2, then you're using 2 lines to cut. Now, because they're not parallel, right? 2 lines are not parallel. They say can't be parallel. No 2 lines are parallel. So it has to kind of cross like this. How many regions do you have? I have 1, 2, 3, 4. So R2 is 4. Are there any other ways to cut such that you don't have 4? Some people, so don't copy this part, or you can copy if you want. So some people say, oh, how come I can't cut like this? And I only have 1, 2, 3. What's the problem with that? If I do it like that, how come it's not 3? It's 4. I'm telling you this is still 4. Why? So how can I say that this is not possible and this is the only case? Why is this not a case? Nathan said the plane is infinite, so they intersect outside the rectangle. They will eventually cross over anyways. Very good point. So if you look at this, right? This is an imaginary boundary. This doesn't actually exist, okay? This actually expands infinitely. And since they're not parallel, right? These 2 lines are parallel, so it will cross somewhere here. And the plane will actually still be defined into 1, 2, 3, 4 regions. Okay? So no matter how you draw it, it's going to be 4 regions. Okay? So next one. We're going to try to find a pattern. Okay, n equals 3, which means I have 3 lines. So I can't all be at the same point, right? Because it can't be concurrent either. So it can only be like this. 1, 2, 3, 4, 5, 6, 7. R3 is 7. Let's do one more to confirm the pattern. And he goes 4. This one's a little tricky to draw. You gotta make sure that when you draw this one, at least any two lines intersect. Okay, so I'm gonna draw 3 first, right? And the fourth one, I'm gonna draw like this. Like this. Okay, so yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Okay, so here's the pattern. Here's the sequence, right? I got 2, 4, 7, 11, right? And then it keeps going. What is the pattern here? What are we doing? What is the pattern? It's 2 plus 3 plus 4, right? So Rn plus 1 equals Rn plus something, right? You're adding something. Same thing, similar to the previous one. So let's see how much when n is 1, you went from 2 to 4, right? That's a plus 2. When n is 2, you went from 4 to 7, that's a plus 3. When n is 3, which is at 7, you went from 7 to 11, which is a plus 4, right? So plus 3 plus 2 plus 3 plus 4, that's plus n plus 1, right? Plus n plus 1. Okay? So then R1 is 2. Okay? That's it. You have 2 parts, a recursive and the reference. Okay? All right, so that's recursive, right? Recursive. The other one would be explicit. Okay, recursive versus explicit. Now, explicit is a little bit like the problem we've done before, right? 2, 4, 7, 11. This is the one that we kind of done before, which is on the previous general section. So here I'm going to use the special method where I recognize this pattern as similar as 1, 3, 6, 10. Remember this one? 1, 3, 6, 10. We did this one multiple times. This one is actually n plus 1 over 2. Right? This was the pattern for that one. And since I'm one more, right? Each one of them is one more to get to the one I want, right? Plus 1 each. So it will be this instead. Okay, this is one of the problems in our previous homework, I think. 2, 4, 7, 11. And we decided to do it with 1, 3, 6, 10. And then this is pretty much the easiest way to do this part. The even more intuitive way, a straightforward way to do it would have been, well, I will introduce it on the next part, which is the series part. Okay, then at that point, it should be a lot more obvious why this works. Okay, but for now, we're doing patterns, right? So, and here we're focusing on recursive, so we don't have to worry about this kind of stuff. Okay, last problem. Each day, 8% of quantity of radioactive iodine will decay. So you want to write a recursive equation to show this. So recursive. So what? Qn plus 1, right? Quantity is equal to Qn. Hey, if I want 8% to be left, 8% to decay, how much do I have to have left? How much do I have to have left? If 8% needs to be decayed, how much do I have left? %. So since it's 92%, you have to put 90.92 multiply here. Okay, that's recursive. Now, is there a way to find the first term, or does it even matter here? Because recursive, usually we have two parts, right? We have the recursive part and the Q1 part, right? Is it given what Q1 is right now? It doesn't matter, right? Whatever you have 10,000, then it's 10,000. If it's 20,000, it's 20,000, okay? It's the beauty of exponential decay, okay? Now, part B, we're talking about half-life. Remember what half-life is? I think we talked about half-life in exponential decay before. Half-life what is half-life? When it decays to half, the time it takes to decay to half, right? The time it takes to decay to half of original. Well, original is kind of like in parentheses because anywhere you start, the amount of time to take to half in an exponential decay is the same. So for example, the amount of time for me to go from 10,000 to 5,000 is the same as going from 2 to 1. Okay, it's the same amount of time. It is a game, Brandon. Do you enjoy playing that game? Alright, so if you have an initial amount, right? You have an initial amount. Let's just say Q0, okay? That's the initial amount. You multiply 0.92 multiple times, right? N times. You will get half, right? You want to know when you get half. So half of that, okay? How much time would it take me to go half of that? So you gotta solve for this, right? Cancel out the Q0. So this is why Q0 doesn't matter in your half-life, okay? Because they cancel, okay? All right. So how do I solve something 0.2 to the n power? How do I solve this exponent given this? Anyone remember? This is kind of an important skill to solve for exponents. Any good idea? Log. All right. You can do any log. You can do log base 10, log base 2, natural log. I'll just use natural log because save some ink. Why can I use log? Because you can pull this n down, right? So you get n natural log 0.92 equals natural log half. Then divide it over, right? So n is equal to natural log half over natural log 0.92, which is approximately does it turn out to be 8.5 days. Okay. How are we doing? Good? Okay. Level 1 to 10. Give me a number. Give me a number. Level 1 to 10. On recursive sequence. 10, 7, 8, 8, 8, 7. I? Should tell you that I doesn't exist from 1 to 10 because it's not on the number line, but might prove to be too nerdy. So, alright, so if that's okay, then I'm going to talk about some what's your homework. So homework has 2 parts right now. I actually might be able to, but I don't want to do it right now. Okay, so part 1, we're going to do a formative assessment. Okay, listen very carefully because otherwise you're going to miss this. Formative assessment, this is 3 problems. You can find this on Pearson. Okay. Due by end of today. Okay? Go do them by today. By tonight, 11:59. Okay? Don't ask me to go open up for you. Okay? Please don't. Only 3 problems, shouldn't take that long. Okay, this is to help me grasp your knowledge on this. Like 1 to 10 is good for your confidence, right? But I still need to see some real stuff. Okay? If you do it wrong, you did it wrong. Okay? I think you have like 3 chances to change it. Okay? So formative assessment, 3 problems by today. Number 2, Google Classroom. There are 2 worksheets. Due, I think Sunday. This is Sunday night. Okay. So, do that. And, yeah. Okay. Any other questions before we go? Logistic, conceptual, both are fine. No? We're all good then? The assessment is not timed, but you have to finish by today. It's kind of like a homework that's due today, right? Think about it like that. But you can't fix it infinitely many times. I think you get 3 tries. Okay. So half-life. Half-life is because you're trying to calculate how many days it takes for any initial amount, let's just say x, to go half an x. Okay, so I put into formula like this. You can do it multiple times if you want. This is a general formula for exponential decay or geometric sequence. Is basically how many days do I take to get from my initial amount to that amount. How do I get this number? You just do it over and over again. Your Pearson page is blank. One sec. Okay, so let me make sure the Pearson assignment is open. Oh, apparently it's there. I think it should be there. Patrick, if yours is like the whole page is not loading, you need to go to your browser and clear out your cookie. So clear your history page, I don't need to know what's in there, but just clear and go advanced clear to clear all the cookies as well. And reload or close it up and then do it again. Okay. Anyway, so going back to the half-life issue, the way I calculate it is you can think about how you use so you need to find how many days it takes to get half, because every time when you do this decay, you multiply it by 0.92, right? So this is how many times you multiply by 0.92, and this will show you how many days does it take from a certain amount to half that amount, right? Half of that. So when you cancel out, you got this, right? And the reason why I use log is because log has a property for me to pull this down. Okay, pull this down, and then I can solve for n because that's a property, right? Is that okay, Allison? Did I successfully convince you? Okay, that's great. Any other logistic problem or conceptual problems? Usually Pearson is bad with a few things. Unclear cookies, add block. Yeah, or maybe they're just on maintenance. But since most of us are on it right now, you shouldn't have problem with it unless there's some problem with your firewall or something. But it should be fine. Good to know, Patrick. Good to know. Anything else? Wi-Fi could be a problem too. All right then. You guys know your homework, right? It's all posted over here. So nothing else. Until next time. Take care. Stay safe. Oh yeah, I did end up shaving my head. But not like you guys can see it or anything. But yes, I did end up shaving my head. Not the whole thing. I left a little bit of hair on top. A little bit. Right now I have to wear a hat to sleep because it's too cold. I get a headache in the morning if I don't. I shaved it like last week? Before last week? You do? I'll show a little bit. Maybe. Let me see. How did I do this? All right, that's enough. Nobody caught it. Nobody caught it. Clipped. Clipping this is like, dude, Nathan, don't worry about it. I'll cut it out. I'll cut it out for sure. Actually, I don't really care. Clipping this is like the equivalent of screenshotting your Snapchat. It's unethical. You guys should know this. It's like screenshotting someone's snap. Unethical. Alright, if nothing else, I'll see you next time. Goodbye.